Okay, looking at homework 8.4, problem 1, this is a confidence interval using proportions. On this problem, what we're going to do is we have a distribution table that we can use, but what I will ask you to use is go into Canvas and pull up your proctored final exam formula sheet, and you will have this critical score table. So what we know from that is if we want to find the 0.99 confidence interval, we will use 2.575. So that will be our number. So you can use that table to help you work this problem. So with that being said, we are going to find, first of all, the standard error of the proportion, which is the square root of 0.45 times 1 minus 0.45, which would be 0.55, divided by n, which is 120. So if you calculate that and round it to the fourth decimal place, you will get 0.0454. So we will do our proportion of 0.45 plus or minus our z-score of 2.575 we got from the table times 0.0454. And if you put that in your calculator, do 0.45 plus this and 0.45 minus this, you will get 0.333, and the upper limit would be 0.567. Okay, moving on to the next problem. Question number 2. It's the same type of problem. You will look at your table, 0.99 confidence interval. That's 2.575 would be our z-score, or our critical value. We would have to find our standard error of the proportion, which is 0.80 and then 0.20, and then n would be 450. And if you do the square root of all of that, you will get the standard error of the proportion as 0.0189. Remember to round to 4 decimal places. So you're going to do 0.80 plus your z-score, which is 2.575 times 0.0189. And you're going to, when you do plus, you would get 0.849, and you're going to do 0.80 minus 2.575 times 0.0189, and you get 0.75. Question number 3. You can use the table here, but they're only wanting the margin of error. So all you will have to do is remember our z-values. For the z-value associated with the 0.90, let's do it first. 0.90 z-value is 1.645. So 1.645 is our z-value, and then your standard error would be the square root of 25 times 0.75 divided by n, which is 120. So if you do 1.645, and when you work the second part out, you should get 0.0395. So if you do 1.645 times 0.0395, let's see, let me make sure that that is right. 1.645 times 0.0395, you get 0.065. That is correct. So for B, you're doing a 95% confidence level. So our z value would be 1.96. The standard deviation in n is still the same, so you would do 1.96 times 0.0395. And then for C, 99%, you would get 2.575 times 0.0395, and you will get your answer to the left. Okay, moving on to the next problem. Question number 4. You're going to do the margin of error here, doing the same way you worked number 3. Moving on to let's look at question number 5. Now on question number 5, they don't give you the table. Okay, so on this one, you don't have a table. So you're going to actually work this in StatCrunch. Because if you look at the example, it says using technology. So for A, we need a upper and a lower limit. So we're going to go to Stat, Proportion, One Sample with Summary. And the number of successes here, it looks like 196 out of 320. And then we want a 99% confidence interval. And then we're going to compute, and you will see the lower limit is 0.542 and the upper limit is 0.52, 542, 0.683. What is the margin of error for this sample? Now, to get the margin of error, you take the z value and the standard error. So the z value for 99% confidence interval, if you look that up on your table, the z value, let's look real quick, is 2.575, and 2.575 times 0.0, this number right here. We don't have to calculate it. So 2.575 times 0.0272, and that is how you get 0.070. Now, because the confidence interval, our confidence interval, 66% is in between 54 and 68%. So since our confidence interval found in Part A includes the reported proportion, that means that it does not provide any evidence that the proportion has changed since it is within this confidence interval. There's no evidence that it hasn't changed, that it's changed. Okay. Now, if it wasn't in this confidence interval, then we could say, okay, well, it's not in between these two numbers, so something has changed. Let's look at question number 6. You're going to work it the same way. You're going to put it in. You're going to put these in just like I showed you on question 5. But here, 62% does not fall in between 66 and 76%. 62% is below the lower limit. So because the interval found in Part A does not include the reported proportion, the sample provides evidence that it has changed since then. And then question 7, you work the same way as you did 5 and 6. Question 8, you work the same as 5 and 6 and 7. And question 9, you work the same. So all those are worked the same way. I have time, so I'll review that one more time. You go to Stat, this is a proportion stats with summary data. How many successes did we have? Well, we had 650 observations, and 115 of those smoked. And we know that we want a 95% confidence interval here. So we're going to hit compute. And you can see your lower limit here is 0.148 and your upper limit is 0.206. Now to find your margin of error, you take your standard error, which is 0.0. We have to round this to the 4th decimal place. So it's going to end up being 0.0150. And then you're going to times 0.0150, the standard error, by the z-value, or the critical value. So the z-value associated with 95%, if you look in your chart, the z-value is 1.96. So you're going to do your z-value, your z-score, 1.96, times your standard error, which when you round it to 4 decimal places is 0.0150. 1.96 times 0.0150, and you get the margin of error of 0.029. And then 19.3% would be in between 14.8 and 20.6. So it's in between these two numbers. So since it's in between these two numbers, we can say that the proportion has not changed.